I might be a studies engineer and you're a structural engineer, and being able to have conversations about what it is that you do face to face. I learned better from the different disciplines, electrical as well, right?
You didn't just read the solar pile design wiki page?
No.
And that didn't tell you everything you needed?
Tell me everything.
All right, welcome back to the Sounds of Solar podcast. I'm your host, Chris Brew, and I'm joined by some distinguished gentlemen.
Prahlad Shivshankran here.
Russell Hamilton here.
Yes, excellent. And today on the show, we're going to be talking about EVS as a one-stop shop, a one-stop consulting firm in the world of utility scale and distributed generation solar. Before we get to the actual subject matter of the episode, let's talk about the real important stuff. What'd you do this weekend?
This weekend? Well, not a whole lot, but I did get a chance to watch the last sprint car race at one of the most historic racetracks in the country.
Which is?
It is the Devil's Bowl in Mesquite, Texas.
Okay.
It's the birthplace.
Is there a barbecue down there?
It's amazing. It's the birthplace of the World of Outlaws. And if you know anything about sprint car racing, they're the top dogs in the world.
Oh.
So like in the 1970, I think it was 1978 or 74, it was the first outlaw race, and it was there. So it was a very sad time.
What is it? Oh, the team
it's the league,
is the Outlaws.
It's the league.
The league is the Outlaws.
Yeah, World of Outlaws. Sprint car
That's
racing.
a great league name.
Yeah, got to watch that. Those last two races there, and the owner sold the property, and it's no longer going to be a racetrack. So
so you were there at the right time.
Well, I wasn't there I have been to that track.
Yes,
but I unfortunately, couldn't make it down there.
Sure.
Actually, I was down there for work.
Mm-hmm.
And the folks I was with, I was like, "Hey, let's take a little detour," and they weren't into it. So
what?
Yeah, it's all good.
Man, if I was there, that's
Shout
the
out
only thing we
Logan.
would have done.
Appreciate you. But no, it's all good. So yeah, I was able to watch that, and that was really cool.
What's happening in your world, Prahlad?
So last weekend we celebrated Navratri, which is a festival in India. And then this weekend I have my wife's friends are coming over. So hosting them and then kind of showing them Minneapolis. So a bunch of them flew in from Buffalo and New York and some from Arizona. So just gonna show them around.
Mm-hmm.
So I'm the driver.
How about you? Any races lately?
Racing and playing and racing and playing and whatever else.
What was the big last one that you did? The one up in North Shore?
Yeah, I did. I did that. That was a little while ago. Heck of the North. It's a 100-mile gravel race. It was wet. It wasn't raining though, but it was very wet.
It was very muddy.
Yeah, it was. You should see a picture of my bike. The drivetrain is completely like solidified in mud. Like you couldn't even, after it all dried, you couldn't even backpedal the drivetrain. It was just completely frozen. Wow. But then I cleaned it all off and it worked great. So
nice.
I'm actually
I have
curious,
good luck like that.
Like, what's your recovery rate after like a race?
Just go ride the next day.
Seriously?
Yes.
So how much protein are you drinking?
If you ride every day, you never get sore.
Exactly. Yeah. No, honestly, it works like that. Like I went out and done this race in Colorado called Breck Epic. It's a 6-day mountain bike stage race.
Mm-hmm.
And like the first day you're like, oh boy. And then the second day is like, oh. And then the third day you kind of come out of the dip and then you just like ride it out on the way out. And like I usually had felt the best like day 5 and 6 in that race. And you're at altitude, so you're also acclimatizing to that. And it's, so.
That's curious because I just did not too long ago, I did my first like through hike up in the North Shore, and it's been 3 days hiking and camping on the trail. And that third day I was wrecked.
You were
we
toasted.
were all wrecked.
Yeah.
And I thought the next day when I got home, I thought I'd be just in horrible shape. Actually, I felt pretty good. I was surprised.
You flushed all the lactic acid out.
Yeah.
You're good.
Yeah.
What we want to talk about today is EVS as a one-stop shop, which is definitely the truth. We can do pretty much everything for a solar project here. And what does that mean?
Yeah, I think for me, turnkey solution sounds, I think is what EVS does.
It's a buzz term, but it's real.
But it is real, yeah. So, but yeah, like I think just since we have a lot of disciplines in-house, it makes coordination a lot more easy.
Can you name all of them?
Electrical, we have, the way EVS does it, we do electrical design, PV and BESS design, and then we have a studies group that focuses more on electrical studies required for these designs. Then we have structural, we have civil, we have geotech, we have surveying, we have
substation,
hydrology, and substation too, right? Yeah.
Yes. Hydrology is kind of lumped into civil.
Civil? Okay.
So
yeah.
And then we also have an MPM group, multidisciplinary project management group, which is a new thing. We'll talk about that later.
Yeah.
But I think you kind of hit that. Russ, how would you describe one-stop shop?
Turnkey is obviously the catchphrase for it, but I would say it's just, we can do every phase of utility scale from, early investigation with geotech, going out and doing that early investigation to all the way to the end of it, commissioning, support. So everything in between, we can do it all.
Right. And a lot of the benefits there are, we can talk about internal communication, I think, is probably one of the biggest selling points of why this is a great thing for our clients and a way to build a project. But why is that? Like, what does a client benefit from the one-stop shop versus using sub-consultants for every discipline? What would you say, Russ?
I would say coordination, probably, and efficiency. I do know that we had gotten some feedback from clients that the reason they don't typically hire one-stop shops is because they've seen in their experience that, civil team's not communicating with an electrical team, not communicating with a structural team internally, is causing design issues. We heard that feedback, took it seriously, and created an NPM group. Our NPM group acts as a mediator to make sure everybody's coordinating and having all of our design inputs shared amongst each other. And so benefits are things like civil has a change. They get up from their desk, they walk over to the PV person and say, hey, this change is happening.
If you're in the office.
If you're in the office, or message. But, it's very efficient, it's very quick, having that kind of communication. Some of the struggles we have when it's out of our company, a civil or a PV, whatever, getting that communication, maybe send an email, send a follow-up email, send another follow-up email, give a call. Sometimes you don't get the information in a very timely manner. The other benefits I would say is, if we see a problem in some design, we're able to say, hey, hold up on what you're doing. We have an issue that's going to affect you, but we need to solve it. Let us solve it. Then we'll work together. And that way you're not, you're being more efficient with your time.
Yeah, definitely. I mean, you probably see this all the time with electrical, coordinating with civil, and having that dynamic relationship, right?
Yeah, I think and it's a good learning opportunity as an electrical engineer as well. Like, I think a lot of times you just get siloed thinking, okay, I'm just going to focus on electrical. And I think as like, just say EVS, with all the disciplines in house, you start to take more ownership. I think that's the biggest takeaway.
There's so many inputs.
Yeah, so many inputs, and you need to care about all these inputs, right? Yes. Sometimes as an electrical, you're like, I don't care what civil does. Like, I did my job. Why do I care what civil did?
Care about
exactly. Yeah. So like, maybe civil needs location for the basin, for example, on a project that I worked on. Like, I had to coordinate with them early, so they put the basin in there, and then I work on the best yard and make sure that sits in place, and I also work with substations. So I think there's a lot of advantages working like with everything in house, but at the same time there are challenges as well. So, and it is a learning opportunity, and that's why I think the MPM group does a pretty good job of making sure that everybody sticks to the scope, and
they maintain that communication with the client too, because it's not like, in the one-stop shop that we're doing stuff and then suddenly it's done and then we just present it to the client. There's always that chain of communication, but I think we gain those efficiencies behind the scenes. And then now we have a representative in the MPM contact that just really drives it home for everyone.
Yeah. So instead of having 4 different people as your contact point, you've got a central contact point. Obviously, we still, as the projects evolve and move, it's not that individual PMs aren't having conversations with the client, but there's a very central person of, if the client's saying, I need an answer to something, they have one person that they can go to who knows they're going to get that answer for them, regardless of what the situation is.
Yep.
And I think speed of response is something that's also valued. Like, for example, like if you work with somebody external and their whole scope is just substation, right? They may be doing substation for 3, 4 people or 5 people. So your response time is, again, you just send a Zoom message.
Right.
And it could be as simple as like, hey, I just need a substation geolocated, for example, right?
Yeah.
That shouldn't take a week. That's a day's task, less than a day's task,
exactly.
half a day's task. And that's something that, like, with all the disciplines in-house, it's a quick message and then
It is. It definitely is, yeah. So things like that's a great example on how all of the teams contained within the same unit, but then with a central figure to help coordinate that with an external clients is it does work really well now. Not
So-
that it didn't before, but like,
Right.
you know, when you're a technical project manager, you have to parse out so much information day to day, and you're managing the technical deliverable, which is like, that takes a lot of brain power already. And then offloading even just 10% of that to a central figure, it makes a huge difference. And we've noticed that in-house. I think everything now is flowing at a much like that I mentioned that 10%, but the return on investment of that is way more than just like, oh, we got 10% more.
Right. So tell us from a structural standpoint, you know, as we're electrical, you know, how does structural and civil intertwine, and how is the MPM?
Oh, we just butt heads all the time.
Sounds right. We butt heads too. So
No. It always varies. You know, it depends on the project. It depends on the client. It depends on a lot of different parameters. But like, you know, it is so simple though too, because, you know, each project will have a chat or something, and people are very active on there. And like, just getting that information is relatively simple. And, you know, it can just be as simple as like, hey, what's the high water level at this location? I'm designing the cab system for the structural component. What's the high water level? What's the scour? And we were talking about inputs earlier, and that's something that's so mind-blowing in solar that is so different than traditional buildings, is that your inputs are dependent on other disciplines and things that they're not defined in a code. And typical building structural engineering is like, I'm living and dying by the code. That's it. And that's how you're kind of trained to think in a way. I think a lot of engineers fall into that trap of, what does the code say? Well, what does the code say? Well, I mean, that is important to an extent, but like in solar, there is such a wide array of other things that you have to think about. But that's where having that stuff in-house, like take that example I just said, what's the high water level at this location? And to think that all I have to do is send a Zoom message to homeboy over in, or, you know, wherever they are, versus prepare a question for the client thinks about it, and the client redirects that to their subconsultant or whatever. And it's that like efficiency gained is like, because once it goes out the door to the client, you don't know. I don't know. When is it going to come back? So these are the things that, like, I mean, I think put us into a very strong position that we can service the client. We can better build the project. I mean, it kind of the list goes on of why having all the disciplines in-house.
And where does structural typically like come in? Like maybe it's worth mentioning how we do the projects phase by phase. I don't know if just going from like a 10% to 30%. What I've typically seen is structural comes in maybe at a 30% stage. Is that true? Right.
Yeah. Typically 30%. And, you know, I think our listeners are probably maybe aware, maybe not aware of how a solar project works. There's usually 30%, 60, 90, and then IFC. When that's the IFC is issue for construction. That's,
or IFP.
There's IFP in there too.
Post IFC,
and then there's IFR, but that's our aviation background.
Substation design.
That's instrument flight rating.
Oh, for me, it's issue for reviews.
Oh, issue for review. Okay, this is the kind of the flow of the projects. And structural, back to your question, I mean, I think we get serious at 60%. We don't usually issue drawings for 30%. We will, of course, if someone asks us to, but 60% is when we have enough design parameters in place that we can issue for procurement, typically. But anything, you know, be earlier than that is just not possible. The electrical design hasn't been flushed out enough. The civil hasn't been, the hydrology is not enough. You know, it takes a lot to get a project to that point where it's like, this is how tall and how big this pile needs to be, which for any listeners out there, the fact that solar pile design is so unbelievably interesting and complicated, I never would have thought that ever. It's just literally a piece of steel jammed into the ground, but it's a lot more difficult than that apparently. So
I guess one of the things I do want to touch on that I think is important is understanding how all of our disciplines actually work together. So you're saying, you know, structural stuff comes in at 60%, but like your design or the structural design is so key to portions of our studies, specifically the grounding study. So like your pile design for the inverters, your pile design for the trackers. We have to have that information before we can even do our grounding study. So it's very intertwined of like, we need
cyclical.
that information.
It's just like chasing your tail all the time. And then is it galvanized or not? And that's something that's like changing a lot these days, is that, we'll run designs for a galvanized scenario.
Is galvanized? You should just...
Oh yeah, galvanized is basically it's a piece of steel that's been dipped in a zinc bath, basically, and then it provides a corrosion resistant coating, which makes sense because we drive these things into the ground. The corrosion in the ground is much worse, like astronomically worse than corrosion in the atmosphere. So the piles will always be silver, shiny looking. Well, maybe not shiny, but like they'll look good in the field, and then underneath, 10 years from now, there will be a lot of corrosion that's happened and degraded, and that drives our design a ton. Like that's everything, is the corrosion rate, and then what the thickness of the pile is going to be on the last day of service.
I was just asking, like, how, so structural, you see how it affects studies. How does it affect civil? Like, how are we all intertwined?
And I think
not civil, sorry, electrical, and then
what
also
is it you do around here again?
No, but one of the main things is like I feel like 30% submittals or 30% stage is very crucial for, I think, procurement. I think that's why, like, at a 30%, I think you guys come in at a 60% stage, but at a 30%, we want to get the high level stuff flushed out with respect to quantity of inverters, how many trackers, those kind of things, so that purchasing, or whoever is purchasing it, like the owner purchasing it, knows exactly, okay, how is it going to look? And then they can add in some kind of buffer in there and start doing procurement early. And then at the 60% stage, once we flush out the design, they know exactly what they're procuring. Then you can procure the steel. And then you go
such a long lead time, right? And then you need to get that. Well, for all the equipment, it's
everything. I mean, the quantities are insane. I mean, like I mentioned maybe earlier on the first episode, like we're talking like 50,000 of these driven piles. Like it's like incomprehensible. And they drive, maybe one team might drive 200 a day, and there might be 3 or 4 teams out there. These guys are driving piles like
for months,
all day, every day.
Is that a machine, or is it just physical? Come on,
it's just sledgehammer. The sledgehammer. No, I got it.
No, it's a machine, and actually, and we'll probably touch on solar tech in a future episode. But there are literally fully robotic pile driving machines on the market now, which is just like, really? Like that's just
that's
crazy.
A good topic for a future episode. There's a lot of interesting new technologies.
It's just so much
for
tech.
Construction that they can do. Well, I wanted to touch on something you were just bringing up. A lot of folks, even early on into my career in solar, unless you go to a site and a site visit, you really can't grasp how large these sites are.
So huge.
And it's I would encourage anybody that hasn't been to a site to go. It really is truly. They're square miles in size. And so you might look at a CAD drawing and you see the whole design and you don't quite grasp how large this is.
Yeah, it's massive.
So it's something very simple in your design of like, oh, well, we'll just add an extra one thing on each one thing, not realizing that one thing can cost $1 million across the entire site, things like that, we all have to keep in mind and be
but then going back to the our central theme here is that, like, the one-stop shop aspect. Like, I think the gravity of the site and how big it is and how complex it is, like that is, when we bring it in here, it just simplifies everything so much.
And we go back to last episode where I was feeling the schedule, and like the complexity is going to be a big challenge. Having things all internal helps with that schedule. Where you're not having to wait to go to the client for, hey, I need this from structural from a different company. You're my point of contact. I send you what I need. They send it to them. And then it's, telephone game.
Yeah.
Sometimes you get things back that isn't what you were asking for because the ask wasn't clear, from whichever direction it's coming from. When internal, it's very clear.
Yeah.
Oh, you gave me the wrong thing. It takes me 30 seconds. That's not what I was looking for. This is
especially when you know what that thing looks like when it comes from an internal source, because like, I think that's what you were saying is like, you might be expecting some exhibit that is, you have this idea of like, well, this is what it looked like for this other project, and it looks nothing like what you thought you asked for. And when we're all talking about things internally, we're all on the same page. We understand how these things need to come together, and it's a super big advantage for us, but also for, the project overall.
It allows us to also optimize as well, I think, and try to make more efficient designs, especially if you, like, let's say civil was not in-house and maybe their job is just maybe put a basin in or something along those lines. I know I'm simplifying it, but like if they did have to just put a basin in, they may just go in and just put a basin in without considering the fact that there are other things that need to be done.
Yeah.
And this, with everything in-house, we can start to optimize.
Right.
We can try to figure out what's the great.
You can just look at the electrical layout.
Yeah.
Like, oh, there's MV routing right there. We can't put a base in there. But that's that could take 3 days to have that all make sense.
Yeah.
All right. So let's move on and talk a little bit about what is it like for a project to start and go from start to finish. And my understanding, at least at the beginning stages, is there is going to be a request for a proposal.
Yep.
And so you probably are active in the proposal game, and that's always fun.
Yeah, it's fun.
Well, a client, I mean, if you're looking to do a utility scale solar project, what happens first? Do you want to start with that?
Sure. Yeah. So very high level, we get a RFP.
Yep.
We get a data dump to try to figure out what the project is like so we can propose on it, scope of work, technical scope of work. We propose on it, go through QC, send it to the owner. If we're awarded, then we know if we're awarded the project or not awarded.
Yeah, there's a whole bidding phase that
very
needs
high
to happen.
Level. Yep.
And that's something that we don't know too much about.
So I think it's one of the most important steps, though, to make sure we capture the scope. A lot of times our clients have a different scope than the owner. And so making sure that we're proposing on the correct scope of work.
Right.
So that's another high level.
I mean, the proposal phase is only as good as the inputs.
Yep.
And I think that's gotten a lot better in the last couple of years. Like, I think now when we get these data dumps of information, they're pretty comprehensive.
Yeah.
Like it's pretty much everything we do need to set an accurate price for services.
So then after we get awarded a project, we have a kickoff call. We have an internal kickoff call where the person who did the proposal kicks off internally to the team that's going to take it on to make sure that we're all on the same page of understanding, why the proposal was done the way it was done, the scope of work at the time of the proposal, that's what we propose on. And what the value of that is when we do a client kickoff call, then we can make sure those are aligned. So if we see something right away of, okay, that was a part of the RFP, let's just make sure we're on the same page. Is this what you want? Is this what you need? Making sure we're having the right stuff. So then we have a client kickoff call. And then after that, once again, we kind of get a data dump, updated information. And for electrical, 10% design.
Yeah.
With 10% study support.
What does a 10% electrical look like? And what is it dependent on?
So we basically need like equipment data sheets. I think on a higher level, that's kind of what we need. So let's say for PV, for example, you would just need tracker information. You would also need what kind of inverters you're going to be coupling with. So that you can, I think at a 10% stage, what you're doing is maybe working with something like a PV case to get trackers in.
And all this information is provided by the owner because they have either procured this equipment or they're going to.
Yeah. Because like I said, like the 30% stage is where they're actually going to procure stuff. So they just give you like a ballpark of what they're thinking, what's in the mind. And then once we flush out like a design and just give them a preliminary design where there are trackers in place, there's inverters in place, there's a preliminary MV routing done. Once we have all those, because they'll have to procure cables, they'll have to procure the inverters, the power converting units, they'll have to procure the trackers. So all these things need to be, on a high level, they just need to understand how things look. So at a 10% stage, that's kind of what we would give. And we'll work with studies closely to kind of evaluate what's the best, how many inverters we should,
how much civil input do you need at this time? Or is it, there not really any?
I think for the most part, BAM is what we need. We need like a BAM.
This is buildable area map.
Yep.
Buildable area map.
So, because electrical.
Not Emerald.
No, it's not BAM.
That's old.
I mean, it's BAM for us. The minute we get the BAM, we just start rolling. So, But yeah, we need like a buildable area. And what that buildable area is, this is where literally we can build. And that's where we can physically put equipment. So, and that's defined by civil, and civil is looking at things like tree line. They're looking at water bodies in and around the place, like what is jurisdictional wetlands, what is non-jurisdictional wetlands, is there utility poles? Because we can't just go in and just build wherever, right? Like we just need to, they're defining our constraints. And once the constraints are defined, we go in there and then we place our trackers in. And it's close coordination, to be honest, even at a 10% stage.
Right.
We can't like just be showing a client like, hey, I'm putting trackers on top of like a tree.
Yeah, exactly.
That they don't think that they...
That's probably new. That's a new tech episode in the future, tree trackers. So that's 10% electrical.
That's 10%
on the structural side, I would say we don't have any involvement, 10%. I mean, what was always said to me is that we make stuff so other people can put their stuff on our stuff. So you got to figure out your stuff first before we can figure our stuff out. We have a civil guest here at the moment, or a host, but civils, they figure out the buildable area map. They're established, like you said.
At 10%?
Oh, I believe they do grading at 10%.
They're probably looking at that, and then tree clearing, etc., and like all these like factors that...
Because again,
wetlands, basins, etc., like general layout stuff, general hydrology,
everything. Because again, at 30% stage, they need to know how much of tree needs to be cut, which AHJs they need to go and approach to figure out if this tree can be cut. I think one of the projects we worked on, there was tree clearance was limited to a certain acreage. So, and there was bats on the site. So those are the kind of things that you're going to have to look at.
There's
environmental impacts.
Environmental impacts are something that I never thought about before this. And, the fact that there's the bat thing, bat ththing is like, that's come up numerous times where it's like, well, we can't remove this thing because there's a bat species that is their habitat. So what are we going to do?
There's a project in California that I'm working on where there was, I believe it was a ground mole or something like that dictated where they could build and where they couldn't build, So it's definitely something that goes into the entire design process. But moving on to like a 30%, like you were saying, 30% is where the quantities get a little bit more defined.
Things get real
for electrical. And
what we do is like we basically provide like a typical, what we call we define typical blocks. So we kind of go through the entire site. We're like, okay, what are the similar looking blocks, and we call them typical blocks, and then we have a block that's atypical, which doesn't look like the rest. So like we were discussing earlier, like sites are all spaced out now. They're not cookie cutter anymore.
They're not squares, which would be perfect if they were squares.
Yeah, they're all squares, and every single power block was
so the same.
These are all 20 megawatt power blocks. They're all just kind of
exactly. So those, if it's nice squares, we would be like, okay, this is a typical block, and then there's one that looks kind of weird, so that would be classified as an atypical block, and we would just start doing like a DC design and for those blocks, so that
in 1 second, a power block, how would you describe a power block?
I think you could define it as the number of trackers associated with a single
inverter, right?
Inverter. So that the boundary would be classified as a power block. So we would, if there are 40 power blocks on site, we would do maybe 5 typical blocks, and the main thing again is to establish quantities. Again, like goes back to the fact that 30% stage, they need to really kind of figure out on what's the ballpark number of trackers, equipment, cables, those kind of things. So the reason we don't do like a full DC design is because a lot of things are still not flushed out yet. So we would do, for 5 power blocks, we would get the quantities in and use those to interpolate like the values for the rest of the power blocks. And then the quantities for the entire site is known at that point. And then they can start looking into, internally, the clients could start doing analytics to kind of figure out which equipment is better. Can we do less cabling here? Those kind of things. So I think, So
and meanwhile, the civil folks, we'll characterize it as best we can. They're working on grading. They're optimizing hydrology, optimizing grading.
They're moving dirt.
They're moving dirt around.
Love you, civil guys.
Putting some water around. Yeah, we'll get a civil person on here, maybe. We love them. They're great. But all that's happening, and on the structural side, we need that information to optimize reveals. What in a reveal is the amount of the pile that's sticking out of the ground. For 30%, we'll get top of pile loads from a tracker manufacturer, and that's going to get us in a ballpark of like what the design is looking like. And for any tracker, there's 6 to 8 different pile types typically, so it's a lot of design iterations to run on a particular tracker type. And the other input is, like I said, the reveals, and that's dictated by...
What is a reveal?
A reveal is, it's the amount of pile that's sticking out of the ground.
Out of the ground, okay.
And that's dictated by high water level, by grading tolerance, by freeboard, which is, freeboard is a term that describes the clear distance between the edge of the module at full tilt to the top of the high water level. So there's all of these calculations that need to go into place. Sometimes we do that in-house. Sometimes the client does that in-house. But we can't, like, the role that Civil plays here is like, we can't have 13, 14 different pile reveals. Like they're going to grade the site so that there's like the typical reveal and then the flood state and maybe one more. And then think about how that relates to our design iterations. Like we're doing 8 design iterations for a interior tracker, and then you have an exterior tracker, and then you have this reveal and that reveal and this scour. And so like the computational power that is needed to run all of these design iterations is like ridiculous.
Yeah. So
is this a little thing driven into the ground?
Does this start at 30% or 60%?
30% will have top of pile loads.
Okay.
And we'll have a couple reveals probably defined. And we might, like nowadays you've been looking at a lot of galvanized versus not galvanized. So like that's another whole iteration.
That galvanized versus not galvanized has such like repercussions farther than just structural. It's interesting because it's an interesting topic because it's not galvanizing your piles can save a client millions of dollars.
Yes, but it complicates the grounding.
But it complicates the ground. Now it's not a UL listed means for grounding, although technically it's going to perform the way that we would expect it to perform. But it's just not a UL listed, and it makes things.
What is UL? What is this?
It's
Underwriter's
Laboratory. So basically any electrical anything, you'll see a UL listing on it, especially in North America. It's all right. And it just, there's testing that needs to be done to basically say this piece of electrical equipment has gone through this standard testing and it's good for the purpose that it's designed for. And there's a lot, it's interesting. When I was an electrician, we learned a lot about UL, and there's all over the world, they try to fake a stamp and they look real bad. Because like you might have other countries building something and they don't want to have it tested, and they just slap this.
That's one way to get around that.
But so that it's just an interesting topic that you brought up a couple times, like galvanizing versus ungalvanizing.
Does galvanizing mean you can actually touch it physically, like or no? Like a person can actually.
You could touch it if it's galvanized or not galvanized.
Okay.
The problem is that when it's galvanized, now that is a UL listed means for grounding and bonding.
Yeah.
Okay. When it's ungalvanized, then it's not. There are some clients who have gone out, had that ungalvanized pile tested by UL and have had a certification saying this is good for grounding and bonding.
Specific.
But it's project specific and it's not cheap. And, it's just an interesting topic.
Right. Well, I want to bring us back because I think we actually missed something in the early stages. We were talking about one-stop shop earlier, but when we start a project, there's some things that happen even before the RFP stage. And that is survey, preliminary geotech, preliminary hydrology, maybe something else I might be
I
missing?
think that's right, because they're trying to figure out if the project, if it makes sense to even move forward with an RFP, right?
Yep.
So I think it's certain early investigation. They're digging holes and taking tests, thermal test locations, resistivity test locations, and driving pile locations.
So these are all services that we offer in-house still.
We do.
Survey, geotechnical. Geotechnical is huge for early project investigation. I just wanted to throw that in there.
Yep.
Moving back, so I think 30%, we covered a lot of information. I think all of that's kind of still relevant as we move. It's the same type of machinations, methodologies as we move into 60 and 90. And where it gets different maybe is that we start getting to procurement, right? Suddenly the layout is finalized enough, the grading's finalized enough, the hydrology, the pile designs, the equipment. Now we start purchasing stuff, right?
And each client purchases at different times. So we have certain clients that like to purchase at a 30%, actually, like things that other clients purchase at 90%. So there's, depends on your client. So for us, at least for studies and electrical, certain clients, we have to have that 30% much more locked down at a 30% because they're going to purchase cables and they're going to purchase different things. Whereas like other clients will wait till like a 90% because they, for them, they're willing to change things after 30, 60, even to 90. Whereas these other clients like, no, 30%, this is what it is. We're not changing it. So we need to procure it at this stage. So just knowing that also is really important. What your client's needs are.
Right. And it all depends. I mean, everyone has different methods of building these projects. So some people can wait till 90% because maybe they're not going to actually break ground for a long time after, but the schedules vary.
They do.
And I think that's their unique selling point too, like, because they're the ones. So we don't do construction here at EVS. We're just the engineering firm, but like construction crews, they have their unique ways of doing things. And some, like Russ was saying, like to have everything flushed out at a 30% stage compared to maybe having iterations allowing for iterations at a 60 or a 90. So I think that's,
So all this is well and good. We've all moved through 30, 60, 90, and then we're going to get to issue for permit. And so then it gets interesting because then we go
not every project for us goes issue for permit.
Really?
So California is going to be a big state where we have to issue for. But a lot of the states we work in, we actually don't have an issue for permit, at least for the electrical side. It's just straight issue for construction. So it just depends on which state you're in. I don't know if that's the same for structural and civil. I just know for electrical, it's certain states require it.
Yeah. Well, I think the jurisdiction typically gets some sort of review in the project. I mean, we are building a project in their county.
Right, but exactly.
The way it's done is different.
It's different.
For sure. Yeah. And sometimes that can be a painful experience. Sometimes it can be not a painful experience.
Sure.
Your mileage may vary.
I think especially for battery projects, right?
Yes.
Where like PV,
California is really stringent. And they're permitting for BESS.
I bet.
For BESS projects, which is battery energy storage systems, those definitely you need permit. You need AHJs to kind of approve on the design, AHJs to approve on, like you guys are talking about UL listing off the product, make sure that the system is listed. So that's a very critical stage because like New York or maybe California, if the UL, like for example, BESS systems need to be UL 9540 listed, which is a system listing where all the components of a battery energy storage system, which is the batteries, the power converting unit, which is the inverter, all need to be tested by a third party like a UL or an Intertech. Make sure that's good. So that certification is critical and it'll be reviewed by an AHJ. And of course, with lithium-ion batteries, you do have fire safety risks, so it's a lot more complicated than like PV. So definitely, like I think at those in battery projects, that's something that for sure, like you need the AHJs to kind of approve on.
Right.
But back to if there is an issue for permit, that's the next stage, and then issue for construction. So the issue for permit allows the county or the HJ to provide comment on the design. That typically can, I've had some projects where that IFP is 10 weeks long.
It can take a long time.
Take a really long time.
And then you're just kind of waiting in no man's land, just wondering what's going on. And that's always interesting because then you never know when it's going to kick back on and then it's time to go and get IFCs ready and then it's going to be time to build. And which when it's time to build, then what is it like on the electrical side? I know, once construction happens on my side, RFIs, this isn't working, this isn't fitting. What is it like on the electrical side?
So a lot of construction support for both. It's surprising how much studies support they need for construction, which is something.
Really?
Yeah. Because they'll look at our design and they'll say, oh, wait a minute. We have a 10,000 foot reel of this other cable. Can we use it here?
Oh, I see.
We can't pound those ground rods in at 90-degree angle straight down. Can we, not 90, can we do 45? There's just different things, or your design calls, your study design calls for this, but that's it's labor intensive. Can we not do we have to do that? Or is there something else we can do? So, there's surprisingly a lot of study support in the construction phase that,
they're like electrical RFIs, but then they RFI studies,
request for information, by the way.
Yeah, request for information. Authority having jurisdiction, AHJ.
I know we throw acronyms around a lot, and it's funny. I will segue just for half a second or side drive. When new people start in our industry, I remember when I had no idea what people were talking about. So I try really hard, for new people are starting, like to make sure when we're throwing acronyms around that I explain what they are. Because you just sit there really intimidated. I don't know what you're
A lot of the so we have a lot of people specifically from Ensenada, Mexico, on our team, and they always had said that the amount of acronyms in the US also in general is just insane. We abbreviate everything. Everything has to have an acronym.
Yeah. Sorry for the sidetrack. So back to the, it's RFIs come through, and it's construction support is very important because you can sit there and you can hold up construction, and that costs money, right? You have people sitting around because they're waiting on you to tell them if they can or can't do something. So
that's always a fun position to be in.
So construction support is extremely important.
Yeah. Especially because design is for us, it's just drawing on AutoCAD. We can just do perfect bends.
Oh yeah.
And the perfect bends, and they're like, well, we can't do that.
It's always perfect in the design software. It's great. And then in the field, it's this is not quite how I envisioned it, but it'll work.
And that's a pretty big support that they require, because if they're trenching and then they're pulling the conductors to the inverter, we are showing them just having 90-degree bends, but on site, that's very difficult to do. So that's why they would come back to us and say, hey, can we do it like this? Is this okay? Would this still pass? So those are kind of things that we would help out with. So,
and then after IFC or construction support for studies, we have a handful of post IFC studies support that we do. Once the design is complete, we'll go back and redo an arc flash study or harmonic study or something.
Is this going to have an on-site component as well, or not so much?
What do you mean?
Well, do you physically go to the site to do anything?
No.
Do you flip the switch to turn it on?
No, we don't do that. For a harmonic study, a post IFC harmonic study, there is a meter that needs to be purchased and installed. We're not doing that ourselves, but we are, somebody needs to go and do that.
But the labels itself, you guys would kind of verify those.
We verify the labels. We print the label templates for arc flash, and then the client will go and who are their favorite label printer company is, and they'll print it. And then I would say after that, we typically try to have a closeout lessons learned.
How do you know a project is done? Someone doesn't just call you up and be like, "Hey, we're done."
Projects aren't done ever.
That's a good point. They're not, are they?
No, I don't know. I've been here. I've been here for 3 years. I closed my first project last week.
Oh, really?
Yeah. Huh. And we were all on site, and they're not even finished.
Yeah.
With construction, but they were starting to commission certain inverters and power blocks. But we just sat down, did a lessons learned with the client, and the site team, and those site visits I feel are very, very valuable. It gets you FaceTime with the client, but it also allows the field does not get involved in design until very late.
Very late.
And so it gives them the opportunity to give us feedback on our design. A lot of engineers, like you said, in AutoCAD, it's very simple, 90-degree bends. A lot of engineers don't visually see the challenges to constructing all the time, right? So it's really good to get that knowledge from the field team of hey, this was very difficult for us to do because of X, Y, and Z, give some feedback on, future design how to do it in the future. And I just think those things are very valuable.
And they're all client specific as well.
Yes,
the lessons learned, because we have so many clients that we're working with that some would prefer to do it one way. Maybe some prefer the 90-degree bend. So I think, again, lessons learned and having a SOP in place, so standard operating procedure in place. So anybody working with that particular client, again, knows that, when it goes on site, they prefer it this way. And I think it's iterative.
That sort of institutional knowledge is hard to, you can only get it by having experience, but we benefit from having everything in-house.
Yeah, so I was just going to bring that all back to the other part of having everything in-house is, and I think you touched on a little bit, is that I might be a studies engineer and you're a structural engineer, and being able to have conversations about what it is that you do face to face. I learn better and more, from the different disciplines, electrical as well, right?
You didn't just read the solar pile design wiki page?
No.
And that didn't tell you everything you need?
Tell me everything. So, but it's just makes much more well-rounded engineers to be able to see, like you said, that experience,
right.
Oh, you can't do that because it's going to affect structural or civil this way, or electrical or studies.
And then next time onwards, you look at a scope of work in more broad sense as well. As an electrical person, you would sometimes just stick to the electrical scope of work, and then as you get experience, I think which is, again, like you said, EVS has that experience and has everybody in-house. We start to look at everything in totality and kind of be like, okay, this does affect electrical, so we do need to consider this. It just can't have tunnel vision. So,
Right on. Well, I think we kind of covered it. That was a good description of how a project goes, what we do here at EVS, how things vary. Anything else to add? You gonna go to a race this weekend?
No, the race season's almost over.
Darn it.
So fun fact is there are 2 countries in the world that race sprint cars. Well, 2 continents, North America and Australia. And so in the North America off season, the Australia is on season. So they're about to kick off.
There's no downtime.
No downtime. So,
let's book a ticket.
But the problem is their races are in the middle of the night.
Yeah.
So, but I catch the highlights.
Well, I know the MotoGP race in Phillip Island just happened not too long ago, and the race time is like 3 a.m. So they're literally on the other side of the world. So
the world finals for the Outlaws is in a couple weeks. I think it's in a couple weeks here. So that's going to be the end of the Outlaw season, and then after that it's just Australia and New Zealand. They're running New Zealand as well.
So, right on.
Canada. See, I'm shout out Canada.
Oh, yeah.
They're running Canada as well, but that's what I say North America. So.
All right. Well, thank you guys for being on the show again today. We'll be back episode 3 in not too long, but thanks for listening. Thanks for watching. If you're on YouTube, remember we're on all the platforms. I think there's definitely not a platform we're not on, right?
Sure.
All right. We'll see you next time. Sounds of Solar Podcast signing off. We'll see you.
Ciao.